Well, probably more than any other topic, I've been asked about the option adjusted spread. And it seems to be a source of a lot of confusion. And it's hard to type out this answer. It's easier just to show you what's going on with the option adjusted spread. And I think what the confusion stems from the fact that the CFA text gives you the example of the option adjusted spread being crowded out with increased volatility for a callable bond, but not a puttable bond. So I'm going to do it with both. So let's just start off to make sure we understand what the Z spread is, and then we'll look at what an option adjusted spread is. For a risky bond whose cash flows are independent of future interest rates, that means there's no embedded options. When we say it's independent of future interest rates, it means we're going to get those coupon payments and we're going to get the future value. And if we want to hold it all the way to maturity, there is no risk of that. We can hold it all the way to maturity. Where the cash flows are dependent on interest rates is when interest rates get to a point where our bond is called from us. So suddenly the cash flows change because we're not going to get those extra coupons. So that's what that means. For a risky bond whose cash flows are independent of future interest rates, the OAS, the option adjusted spread, is essentially the same as the Z spread. And the Z spread, let's make sure we know what Z spread means. It's called the zero volatility spread. So let's look over here. Here's zero volatility. And here's our interest rate tree. And even though we have zero volatility, I've still drawn out a tree for the hell of it. We have high rates and we have low rates. Basically, with zero volatility, we basically have a straight line as far as rates are, or we have the spot rate curve, and that's it. We don't need any other nodes. But if we price out, let's say that we have a callable bond, and there is zero volatility in the market, and we adjust the price of the bond for the option at each node. Well, there's no adjustments to make. The OAS that we arrive at would be the same as any Z spread that we would arrive at. I think we see that. I think that is not controversial. Let's introduce volatility along the way. And now, remember what we're doing with this is we're trying to recover some price. We see some price in the marketplace for a bond, and we're trying to recover that particular price with this tree. And these are, from here on in, this is the spot rate and forward rates adjusted for volatility. And then we calibrate the tree by trying to recover the price of a government bond. When we introduce a risky bond, we have to add some amount of spread to each of these particular rates to recover that price. That's called... well, we would normally call that a Z spread, but because we're pricing out a bond with an option, we're going to call it the option adjusted spread, and here's why. Let's say that we have 10% volatility. We might find that the bond would be called here. And what would we have to do if the bond is called here? If the bond is called, clearly the price is over 100, so we would have to lower the price. So let's say that at 10%, there's only one node where we actually have to adjust the price on this one. Well, let's compare this with, let's look at two scenarios. Let's imagine it wasn't called. Let's imagine that nothing here happened. It wasn't called at all. The OAS would equal the Z spread. In fact, at all these volatilities, 20%, 30%, 40%, if the bond was never called, if the call price of the option was set such that it would never be called, the OAS would always equal the Z spread. It would always equal the Z spread. But here it got called. So what happens is we have to force the price down. Well, if we have to force the price down, what do you think happens to the spread we need to recover the price? Well, we don't have to discount a higher cash flow. Now we only have to discount a lower cash flow. Mind you, it's only at one node, but it's still a lower cash flow. So since the spread is a constant spread across all nodes, and since we have to discount a lower cash flow now because of this volatility, we can do it with a lower rate. We don't need the big rates to discount this cash flow. Suddenly the rate we need, that constant spread we need, just dropped. So the OAS is now less than what a Z spread would be. Now, I'm going to do something here to make my point. The OAS at zero volatility. The OAS at 10%. Well, at 20%, it might be called here and it might be called here. So what are we doing? You got to lower the price. If you got to lower the price, what happens to the spread you need? The OAS drops even more. So we can say that OAS 20 is now going to be less than OAS 10, which is less than OAS 0, which is the Z-spread. See where I'm going with this? Let's go to 30%. Well, it might be called here, here, and here, which means you've got to lower the price here, lower the price here, lower the price here. Instead of just 2 times, 3 times. So now, overall, how much do we need to add to every node? Well, less and less. So we can say here that OAS 30 must be less than OAS 20, which must be less than OAS 10, which must be less than OAS 0, which equals a zero volatility spread. And finally, let's go to 40%. Call, and let's say call. Well, you're calling it more. You got to push that price down. Well, guess what? OAS 40 is going to be less than OAS 30, which is going to be less than OAS 10, which is going to be less than OAS 0, which is what? The zero volatility spread. So what is happening as volatility increases is the OAS is getting squeezed out. So if we drew a graph of volatility and the OAS, at zero volatility we have an OAS here. But as volatility increases, the OAS spread, as I've shown you, the OAS spread drops. Why? Because, well, if you're forcing the price down at all these different nodes, you need a lower and lower rate to continually recover the price. Now keep in mind, we observe a price in the marketplace. The price of the bond is independent of volatility. Imagine an underlying straight bond. Well, the bond itself is independent of volatility. It's the option that is dependent on volatility. So we would be recovering the same price under each scenario, but as volatility increased, the spread of this tree would get wider, and there'd be more nodes at which we would have to call the price, pushing the price down, meaning we have to discount these things back at lower and lower prices. So what happens here is you get something like this. Now, we said that the Z-spread, the formula that's causing everybody grief, is this. Let me clear off some room. Do we got all this? I think we got all this. I'm going to hit delete here, so you can always go back and look at that. I need some room here, so let's go. The thing that's causing everybody grief is this. Z-spread. My writing here, it's late at night. Z-spread equals OAS minus the value of the call option. I'm going to change this formula a little bit so that you can see exactly what's going on now. I'm going to write it out like this. This should clear everything up. Z-spread equals OAS at zero volatility minus the call option. And there you go. So it's the OAS at zero volatility. As volatility increases, the OAS portion of it gets smaller and smaller and smaller. Why? Because the call option gets bigger and bigger. So if you want to think of the Z-spread here as OAS 0, you can think of it this equals OAS 10 plus the call option. And so OAS 0, again, it's late at night, sorry, OAS 0 equals, and let's go to the 30%, it would be OAS 30, which is much smaller than the 10, plus the value of the call. Now, why is the call price going up? There's more opportunity for it to be called. As volatility increases, more opportunity for it to call, so it has more and more value. So the Z-spread is the option-adjusted spread at zero volatility minus the value of the call. Another way of saying it is the option-adjusted spread at zero volatility equals the option-adjusted spread at any other volatility plus the value of the call. I think you can see that. Let's look at puts. All right, now we're going to do puts. And here's our tree again, high rates, low rates, and we observe a price in the marketplace for a particular bond. And that price in the marketplace is independent of the volatility. Only the option is dependent on the volatility. So at zero volatility, our OAS at zero volatility is the Z-spread. It would be the same thing as a Z-spread if we just calculated the Z-spread, because at zero volatility, that put's going to have no value. Let's go to 10% volatility. Well, let's say that we're going to put it. Well, what do we do when we put it? We have to raise the price on this one. And let's say we go to 20% volatility. There we go. We have to now raise it twice. At 30%, we may be raising the price 3 times. At 40%, we may be raising it, let's say, 4 times. Now, keep in mind, this can continue moving like this, right? And on and on and on. So the higher the volatility, the higher the incidence of puts. So clearly, the put will have more value because there's more opportunity for it to be put. Not only that, the important thing is, what are we doing when we put the bond? We're pushing the price up. We're pushing the price up. Well, when we push the price up to recover the same price, we must need a higher spread because we have to discount a larger number. So here, OAS at 10 volatility must be greater than OAS at 0 volatility, which is equal to the Z-spread. And I'm going to skip all of this, and I'm going to go right to this one and say, clearly here, OAS at 40 must be greater than the option-adjusted spread we need at 30, which would be greater than the option-adjusted spread we need at 20, which would be greater than the option-adjusted spread at 10, which, again, greater than the option-adjusted spread at 0, which is, you got it, our Z-spread. So what does this look like? Well, our Z-spread is our option-adjusted spread at 0 volatility plus our put. Whereas for a call, we subtracted it, and that's a big confusion in the CFA book, is the example given is just for a call. Z-spread equals OAS minus option value is for a call. It didn't give an example of a put, which is a shortcoming of that section. It should have at least contrasted it with the put, and that probably would have cleared up a lot of confusion. But now it's the OAS at 0 plus the put. You can also say, well, if the Z-spread equals OAS 0, then we could just say OAS 0 equals what? OAS 10 minus the put, because OAS 10 must be greater than OAS 0 by how much? The value of the put. So the big thing that I think most people were missing is the idea that this is what's happening with volatility. Since we have more opportunity to push the price up, the spread, the option adjusted spread, must be higher for the put. Why? Because when we push the price up, it means we are adjusting the price for the option. That's why it's called an option adjusted spread, because we say it will be put. Now, what we're saying here, this is one last thing as well. What we are saying here is that if at a node it can be called or put, it will. That's not necessarily true in the real world. So in the real world, that equality we just went through doesn't necessarily hold. That is a floor. Typically, one side is greater than the other side. It depends on flotation costs. It depends on reissuing costs. It depends on market frictions, how much all the transaction costs. Just because it can be put or can be called does not mean it will be called in the real world. But in this theoretical exercise at a node, if it's even, let's say, a callable bond's callable at 100 and our node is 100.01, we still cross it out and put 100. We still lower the price. If it's 99.99, if it's puttable, we still cross it out and put 100. That's not necessarily true in the real world, but I hope you get this now.